move on the microphone? And each group, the requirement is different. On a one day, the just the size of the you go to the 6:20 and come back. So what are you going to do the same requirement? So there will be different users to the develop a team program. Okay, so this is the first part, okay, for IE. Okay, before I move on to the next script, is there any question? If not, I'll show the second one in the second year. Okay, now in the second year, alright, remember the first year, the project is a lot more controlled, okay? It's not so open-ended, but there's some element of autonomy, some element where they can exhibit their creativity, okay? Then in the second year, there's only one, we make the scope wider. In this particular design build project, the only requirement is they must use a microcontroller, that's all. That's the only requirement they need to do, to have. Everybody have common denominator microcontroller, that's all. So, this is where there are two design build projects. I will just show you one of them here, alright? So in this particular design build project, okay, again, we list down the key learning objective we want our students to learn, okay? Learn creatively, think, and critically, apply theory learn to solve problems in the context of a substantial project. Strengthen the learning by integrating knowledge learned from different modules, which is standard 3. Get the students to work in teams, which is standard 7. And create opportunities for them to present orally and also to do report. And we'll bring the students through the whole CDIO cycle now. Okay? Earlier on was just from C and CD and a little bit of I because the building part is very rudimentary. Okay? But here now we bring them through the whole cycle to reinforce the whole CDIO concept. So in the first year, in the first semester, okay, we will teach the core technical knowledge. And then in the second term of the first semester of the second year, we will start getting them to build. Alright? So we want the students to define the problem, they have to define the problem. We don't give them the problem. Okay? The only thing we can give them is the area. Area means, okay, this whole class, we want you to think of a problem to solve problem for the agent. That's all. So you go and think of what kind of problem agent people have. And then you devise solution for them. So that means it's a more concerted, the problem is more defined in terms of team rather than actual problem. Okay? So that's the only thing which we want to scope the project. So we get students to implement and fabricate and do troubleshooting, and of course we assess them. Okay? So instead of being given a fixed project to implement, students will conceive the project idea that is original, useful, interesting, and they all must use a microcontroller. Okay? And this chart here, what does it mean? This chart here means that, you see this arrow here is small, then become big, right? What does it mean? It means that in the first term of this, the contact hour is this amount. Because the building part here haven't really started yet. Okay? It's still a lot of theory. imparting to the students. But when project starts, the student really spend, instead of 3 hours, or instead of 2 hours, they really need more time to start building. Okay, so that's where the error becomes bigger, bigger, bigger. And in our timetable, we have built this into the timetable, such that the timetable is free for them to occupy that lab or the workshop for 4 hours. In the first semester, only 2 hours. In the second semester, the second term is 4 hours. Right? So all this requires a lot of detailed planning. Okay? Of course, my guys will timetabling the screen, but they will force it. Okay? We have to push. Okay? Unless if you don't push, this thing will never happen. So now they are appreciating the fact that we are conducting this way. Okay? It's not every week same number of hours. So the student can think of anything. Alright? Think of modern car, whatever. Okay? They can think of anything. For the handicap, okay, for environment, for the elderly, whatever. So the first part is we get the students to apply design thinking again. So they learn it in first year, now we apply again in second year again. Okay? The design thinking tools. Okay? To interview, to observe end user and gather insights. So they have to go around, okay, find out the problem, define their own problem, okay, and then they scope the problem. Okay? And then they may involve them to do sketches and all this and that. We want to see all this evidence of them going through this process. We just don't want them to have one, oh, this is my design. No. Okay? We want to see them going through this process. Evidence of it. Alright? So if necessary, if there are any blocks like so-called flow chart, we also want them to show us. Okay, chart. Alright? So then after that, they will proceed on to designing the thing, either using a street board first before going on to the actual design. Alright? And then we will get them to show and tell. Okay? The show and tell part will require them to communicate. Okay? In the first year they have learned already. So in the second year again, we reinforce it. Just like what Linda was saying, we link them. We want to teach them this communication skill, teamwork. It is not just taught in one module or one course. It has to be repeated in several courses throughout the whole 3 years. Okay, so therefore the course team must link all these things up so that eventually you achieve the objective that you set out. Okay, so the first year we do a lot of show and tell. The second year we do that again one more time. Okay, and we highlight to the students the C&D assessment, how much percentage research analysis, 25% creative idea, how much disciplinary presentation skills. So all these are very clearly told to them. Okay, we do not want them to expect surprises. Okay, in the I part, this is what these are the prizes. Okay, so every time when we have this show and tell, we ensure that there are prizes, there's more competition. Okay, so this is the second year. Then when they come to the third year, that's the big one. Okay, in the past it was just one final year project. That's it. So when they come to the final year, wow, for the first time in life they have to do a project, how to do it. So now when they come to final year, they are more prepared. Okay, because they have been doing the first year, they have been doing the second year. When they come to final year, they are already quite ready already. And we ask them to apply the CDIO in this, they are so problem. So I will just show you a collection of what they do in the final year. Okay, now this is
a solar-powered golf car. In implementing it, a data logger was set up, tests conducted, and the operational data of the solar golf car collected and analyzed. The aim was to study the performance of the golf car and investigate the impact of solar system applications on the environment and the energy storage on the car. The golf car was then tested under practical conditions.
So this is one of them, and then the next video which I'm going to show you is a collection. Oh, I hope it's not hanging.
This is something I've created.
We did a lot of research to conceive the idea.
We spent months getting it correct.
We hope the industry will take up our idea.
Finally, it is ready and operational.
Just for Spinovax.
For Spinovax. Yeah!
Tired of walking, cycling, or driving? How about creating your own personal rapid mode of transport, or PRT? Capable of being assembled within 10 man-hours by an experienced DIY user, the PRT is environmentally friendly, using a battery as its power source, reducing your carbon footprint. Able to move on slopes or flat terrain, the speed and distance traveled depend on the weight of the rider. A flying vehicle that is fully autonomous. The flying machine can stabilize itself in the air and navigate from one beacon to another using indoor localization sensor. Conceptualized and put together over 6 months, the vehicle also has an image processing capacity, so color strips can be used to navigate.
Okay, so I think I cut short the video, otherwise it will be too long. Okay, so next, the third, I have altogether 4 slides. Okay, next part here is about, in the same course again, alright, those of you who have ended in the morning section, okay, these reporting course, in the final year there are many options, okay, and in each one of these so-called options, there are 3 courses there. So the concept, what is so special about this is that, yes, we can start teaching the various courses separately as isolated courses, which I think every institution do that, including Singapore Poly, alright? Or we can try to group them together and teach them in an integrated manner, okay? So that's what we intend to do, alright? Teach them in an integrated manner in the first year, in the third year, okay? They are all together, these 3 modules called Robotic Fundamentals, Sensors, Actuators, and Robotic Programming. This is for those who specialize in robotic options, am I learning this? Why is it going to do this? Why is it not going to do this? So, therefore, that was a problem. Alright? And of course, when they finish this, there's about this MDG, all this disciplinary project that you do. Okay, so I will just focus on this part first. So, before we start, I got an aim to sit down together. Okay, can you sit down together and work out what do you want the objective, the learning objective to be? Okay, so they conducted some survey among the industries and informed that these are the list of so-called attributes, okay, industry wanted. Alright, communication skills, interpersonal skills, management skills, problem-solving skills, self-learning skills, multidisciplinary willingness to become challenge, ability to fabricate and build on ideas and concepts, programming skills, systematic thinking and mathematical skills. And fearless attitude. Fearless attitude means willing to take risks. So this is a very difficult part to teach. Okay? Because we teach them to not to fail, right? We teach them to succeed. How to teach them to fail? So this is something which until today we are struggling. Okay? How to measure failure? More fail, more marks. Can't be, right? So therefore that is something which is very difficult. But one way to do that perhaps maybe is to let them try out, fail initially with a very small percentage. Want to fail early. Okay? Don't fail it. So we want the students to love robots, to live with robots, to sleep with robots, to dream about robots, nothing else but robots. So that is what we want for this